Why should you be concerned with database design? Well, in order to implement a good database, we must spend time designing it first. Many people neglect the designing process because it is time consuming. However, as the saying goes, there's never time to do it right, but there's always time to do it over. How do you design your own database? Let me show you how I do it as we continue building the to-do planner. If you are new to the channel, don't forget to like, subscribe, share, and comment to support the content. Code with Eno. In my opinion, the first phase in the database design process involves formulating a mission statement and a mission objective. The mission statement establishes the purpose of the database and provides you with a distinct focus for your design work. To get your design mission right, make sure it is succinct and to the point. That is, avoid verbal statements that have the tendency to be confusing, ambiguous, and vague. Of course, this is usually determined by carrying out an interview with the owner in order to understand the business. And one of the questions you can ask the owner is, how will you describe the purpose of your organization to a new client? Okay, so right now I have two mission statements. So we can see the first one here and the second one here. But I think both of them kind of like spoke to me. Okay, so I decided to keep the two, and also looking forward to hearing from you guys in the comment section to see which one is more focus oriented. So the first one says the purpose of the to-do planner database is to store project planning data and provide information that supports efficient and effective project planning and execution. So from this first part, I can see two main purposes of our database. The first one is to store project planning data, and the second one is to provide information. This information can come by querying the database. Okay, you query the database and get information that is going to help to support the efficient and effective project planning and execution. So because the main aim of our to-do planner is to permit user to plan the project and also to follow up with the execution of that project. So I think this database mission statement give us two focal points that we can focus on when we are thinking about the database. The second part in the first phase are the mission objective, which represent the general tasks that users can perform against the data in the database. Just like with the mission statement, to get the objective right, we must first free them from unnecessary details. Also, during an interview with the owner, we can have a more general discussion that is conceptual rather than analytical. We might ask questions related to their daily work, what kind of data they use or keep track to complete their tasks, what type of report they generate, what type of issues they believe need to be addressed by the database. So as we can see, I was able to come up with 3 mission objectives. It wasn't easy. So the first one says maintain user information. So I suggested that everything that has to do or everything that concerns the user would be handled by this first objective. So since it is a general task, everything that has to do with the user will be handled here. And we have maintain projects planning. So everything that has to do with creating the project, creating sub-project, linking project with external resources, creating tasks, and so on and so forth will be involved or will be handled by this objective here. And the last one will be keep track of project execution. After we have planned our project, we need to execute the project. And how can our project help, or how can the to-do planner help us to execute these projects that we have planned? For example, we can move the tasks between to do to in progress to done to test and so on and so forth. So this is an example of how our to-do planner can help us to track the execution of our project. So I was able to come up with these three. I'll be happy to hear from you guys on the comment section what other mission objective we can generate from this to-do planner. This phase relies on the philosophy that to determine where you should go, you must first understand where you are. It's likely that the organization you are building the database for is using some type of database that falls in these categories: paper-based, legacy, or human knowledge base. The human knowledge base is based on the memory of one or more employees within the organization. I think the mechanic that handles my car falls in this category. This phase is very important because it determines whether the database supports the business current information requirement, and also help us to uncover existing structural deficiency with the old database. And lastly, determine how the database needs to evolve so that it will support the business future information requirement. All right, so looking at the old system, yeah, I had to take a screenshot of the UI, and here we have the different mode in which a tax can appear, and we have the different tags here. So we can see the first one is tax, where it contains all our tags, something like the backlog, and we have the different stages or the mode in which a tax can appear. So looking at a single tax, we can see that it has the name of the tax, and it has subtasks, and for the subtasks we can actually tick to show it completeness, or untick, and also you can delete them. And here we have a way to update the tax and to delete the tax as well. So looking at this, comparing this to the database, we can see that the database has created an enum where we have listed the different modes, and we see here we have 1, 2, 3, 4, 5. We have 5 modes in this case, but the new system is going to have more, of course. So here we are basically defining just 2 tables. We have the tax, which is called to do in this case, and we have the to do checklist, okay, or what we are going to call the subtask later on. And we can see here for the task we have the description, the mode, and the done time. Yeah, I think all of this will appear in the new system, but we're going to modify some of these names and add more fields to it. And so we can see in a nutshell we have just 2 tables in the old data, in the old system. And since we are trying to create a new system with new features to make it more complex, we can see that the old system kind of like is a subset. The old system is a subset of the new system. So based on this, we have the conclusion. The conclusion is that the database contains 2 important sections of our new system. So we have the tax and the subtax. Most of the attributes of these tables will make it to the preliminary field lists. And for the new system, we will refine the existing table and add more tables to support project, sub-project, links, category, and so on and so forth. So we are at the final phase. So in this final phase, we are going to analyze the use case documentation, the whole system, and any vital document in order to create the class documentation and the class diagrams. Of course, we'll perform this activity iteratively using the following steps. Identify class names and attributes, creating class documentations, identify primary keys, normalizing tables if necessary, and establishing relationships. All right, so for this phase, we're going to model just one class, meaning that we're going to check just one use case. Then I'm going to give out this documentation that contains all the other class documentations that we have here. All right, so we're going to move to our requirement, what we covered in the previous video. And the first documentation here is this UC or use case registration. So we can take this. I hope that's the first one. Good. So we can take this. Once we take this, we focus on this part. We have the use case document description, the precondition if possible, post condition, and constraint. So once we move them here, we can see all those that are in bold are the nouns that we're able to identify. So once we have identified them, we can list them down here. And once we list them down here, we can now analyze them again in order to identify nouns that can be modeled as classes, nouns that can be modeled as attributes, convert all proper noun to common noun, and also convert all plural nouns to singular nouns. So once that has been done, we have our conclusion here. We can see that actors, visitor, and a user are all the same in the system. So I'm going to select one of these. So I'm going for the user. We can see here the system refers to a combination of classes and components. So we won't be modeling the system here. And things like username, password, first name, and so on and so forth will be modeled as attributes of the user actor. So, and the register here could represent noun or verb. So in the context of this use case, it says the actor register. So I guess it is a verb. And we have the login. The login in some systems, the login can be modeled separate from the user, where the login takes care of logging in users. So it's going to contain the password and the username, while the user model or the user class is going to contain all the other details of the user. But in our system, we're going to combine everything in a user class. So, but it's good to know. So we're going to leave it here in case this option is the best one once we get to the implementation phase. So once we have that conclusion, we can come to the user documentation. The user documentation uses a very simple template. Here we state the name of the class, the description, and the relationship. The relationship here is how related this class is with other classes. Since we don't have any other classes modeled yet, we can leave this empty. So for the attribute, based on what we got from the use case, we can put the attributes here. Responsibility is going to be, it can be modeled as method of a class, or it can just be a simple sentence that describes what the responsibilities of this class are. And we have the business rules. In most cases, the business rule is represent constraints. For example, in this case, we see a user needs to be authenticated before planning with the system. So that's a constraint on the class. And the last one, we have complexity that describes the the level of difficulty that you may have while implementing this particular class. In this case, I'm going to just put medium. But we have three cases. We have simple, medium, and hard. So once we have this, remember, like I said, we may have empty fields here. Empty fields because the information we have at the moment does not kind of like give us everything we need in order to fill them. So what you have to do is that you have to go through all the use cases, okay? Because use cases that are stated at the bottom can give you information about use cases that are at the top. So you want to make sure you go through all the use cases, you bring out all the classes and the attributes just like we did here, everything. And once you have that, you will see that you must have gotten nearly everything, okay? But if you don't, you can move on to the class, onto the user stories as well. The user stories can tell you a little bit about the different classes. If you still don't have those information, you can start guessing, okay? You can start guessing based on maybe your knowledge or some research. So once we, for example, here the created date and modified date is not mentioned in the use case or anywhere else, but I know based on experience that to once a class is created, we want to keep track of the time it was created, and when it gets modified, we want to keep track of the time it was modified. So after we've done that, then we can move on to the class diagram. All right, so we can see here the class diagram. So the class diagram has all the different fields, their data type, and the relationship alongside the cardinality. Is it cardinality? I don't know how they call this, but it has the constraint. For example, in this case, we say a project can belong to a single user, one, and a user can contain many zero or many projects. So we have all of these stated in their relationship, and we can see many fields were added based on my knowledge, based on my experience. Many fields were added. And also, once we establish the relationship, we have to make sure we put the foreign key. The foreign key is going to link the two classes together. For example, in this case, this project is linked to the sub project because sub projects are created under projects. So we can see here, since they are linked together, we have the project ID that appears here as a foreign key to this particular project class. The same thing happened with all the other links that we have here. Now, something very special is this. So we're going to come back to this when we are identifying the primary keys. Okay, so to identify all the primary keys in your table is not actually easy. If you want to go through the normal procedure, you're going to first identify the candidate key. So you're going to create a candidate key list. Candidate key lists are just keys that can be potential primary keys. So for example, in this case, you want to make sure that you have the list. The list can be made up of natural candidate key. These are keys that are created from the fields that already exist in your table, or you can create composite candidate key. This is a key. A composite candidate key is a key that is made up of two or more fields from your table. Or the last option is to create an artificial composite key. An artificial composite key is a key that you create and add to your table to represent a key, basically. So we can see here, for example, I can consider this as a candidate key. Remember, the candidate key acts as a primary key, so it should not be null. That it should not be empty. It should not contain duplicate. It should not reveal secret information of the system. For example, passwords. Password is not a good candidate key. Okay, so we have all these rules that we can use in order to identify the candidate key. So let me see if I can have a composite candidate key here. So username and email can be a good fit, or email by itself can be a good fit as well. So we can say email, username. All right. I don't know. Yeah, these two guys can be good candidate keys. Coming here, let's see. I'm not sure any key can be a candidate key here, because name can be duplicated, description, user ID, and so on and so forth. So in this case, this is where you can actually create an artificial candidate key. For the link, I think the URL and the tax ID can be good candidates for can be a good option for composite candidate key, because linking the same resource to a sub project doesn't make sense, right? So you want to make sure for a specific sub project, for example, only a unique URL is linked to it. So we can do this, and we can try to identify all this candidate key. And once we have the candidate key, we can now pick from those candidate key the different primary keys that are going to represent our a single record in our table. But in this case, I'm not going to go through that process. I'm just gonna use a shortcut where I'm gonna describe, or I'm gonna create artificial candidate keys. So we have two artificial candidate keys here. We have the ID and we have the UID. So this is an abstract class, and we can see based on this note, this is inherited by all these classes. So I didn't want to use the line in order to show this inheritance, because it's going to make this diagram nasty. So I just put a note here to represent the inheritance. So here in this case, the ID is going to be used to identify a single record in each of these table. So let's take, for example, the project. So the ID is going to be used to identify a record in this table, but the UUID is going to be used to identify a project or a record in the entire database, because the UUID is unique throughout the database, but the ID is not unique throughout the database. So that's how it's going to look like. All right, so that's it about the database design for now. And remember, in order to implement a good database, we must spend time designing it. But that's not all. Even when we move to the implementation section, we'll be coming back to this designing whenever we want to do some modification or add something new to it. All right, so if you want to contribute, make sure you leave your thought on the comment section. And if you're new to the channel, don't forget to subscribe, to like, to comment, and to share in order to support the content. So in our next video, we'll be setting up our Django project using best practices. See you in the next video.